In this lesson, we're going to be focusing on graphical evaluation of limits. We'll be learning how to use graph to evaluate limits of functions. If you're watching my video for the first time, please support me by hitting the subscription button, like my video, drop your comments, and share with your friends. Now, each time we want to use graph to evaluate limits of functions, let's say we want to find the limit as x approaches 3. So we're going to be considering it as x approaches 3 from the left. We consider it as x approaches 3 from the right, and then if these two answers are the same, then we find the limit as x approaches 3. We say that the limit exists if the left hand limit and the right hand limit are the same. In addition, we're going to be finding f of 3. So let's start. To find this limit as x approaches 3 from the left, we're going to follow this curve. Right, if you follow this curve, we meet at this hole here. Now this hole is a point of discontinuity. I will give an example of that later. It's a removable discontinuity. So as x approaches 3 from the left, we trace the y value, right, that corresponds to this hole. Now this y value is equals to 1. So as x approaches 3 from the left, the answer is equals to 1. What about from the right? What do you think? Okay, we follow same curve, and then we meet the point of discontinuity, which is this hole, and then it is still corresponding to 1. So the limit as x approaches 3 from the right is equals to 1. Now, since these two answers are the same, then the limit exists, and it is equals to 1. The limit approaches as x approaches 3 is equals to 1. Now, what about f of 3? What do you think? Now, if you look at this tree here, you see that there's a closed dot above it. Alright, so this closed dot is the value of f of 3. So you trace it to the y value. So this 2 here is corresponding to this dot. So we say that f of 3 is equals to 2. So this is how to evaluate limits graphically. So let's find the limit as x approaches 1. We're going to be looking at it from the left, then from the right we find limit as x approaches 1, and then let's find f of 1. I want you to pause this video, solve it. When you are done solving it, you play it and know if you got the answer. Now, limit as x approaches 1 from the left, we follow this curve and trace it. The corresponding y value here at the end of this curve is equals to 4. So the limit as x approaches 1 from the left is equals to 4. Alright, this hole also is a point of discontinuity. So let's find the limit as x approaches 1 from the right. We're going to follow this curve here. Alright, so you see that we have hole here, which is a point of discontinuity. Let's trace the y value. If you trace it, you see that the answer is 2. So the answer here is equals to 2. Sorry. Now, since this value and this value are not the same, we say that the limit as x approaches 2 does not exist. So what about f of 1? At this point above 1, we look at the point where we have a closed dot. So this is where we have a closed dot, and this closed dot corresponds to y value of 3. Alright, so we say that f of 1 is equals to 3. Alright, so this is how to evaluate limits of functions. Now this kind of discontinuity is known as jump discontinuity, because the limit as x approaches 1 from the negative side is 4, and then from the right it jumped down to 2. Alright, or from the right it's jumped up to 4. So this is a discontinuity. It's called jump discontinuity, and it is not removable. I'll also give an example of this at the end of this video. So let's solve the limit as x approaches -2. So I want you also to pause the video, try it, and know how far you can go with it. So as x approaches -2, we're going to be looking at it from the left, from the right, then we find the limit as x approaches 2, and then we find f of 2. So the limit as x approaches -2 from the left, we're going to follow this curve, and then the answer here is equals to 1. Then when it approaches 2 from the right, we follow this curve, right, and then the answer is 2. So here we have that 2 is the answer. Then what is the limit as x approaches 2? Since these two values are not the same, then the limit does not exist, because this is a jump discontinuity. Basically, when you have jump discontinuity, just have in mind that the limit will not exist. But for a hole, which is a removable discontinuity, the limit does exist. So let's find f of 2. At what point here do we have a closed dot, a closed circle? So here is it here, and it corresponds to a y value of +1. So f of -2 is equals to 1. Sorry, this is -2 is equals to 1. So let's solve the final question, which is when x approaches -4. So let's find the limit as x approaches -4. Now, as x approaches -4 from the left, we're going to follow this curve. So as you can see, this curve is tending to infinity. So we say that the answer is -infinity, because this is the negative part of this graph. Then when x approaches -4 from the right, we follow this curve, and then it's approaching to +infinity. So this is the answer to this. And then since these two answers are not the same, we say that the limit does not exist. And then what is f of -4? So the f of -4 in this case is undefined, because this is an infinite discontinuity. For example, if you have something like 1 over x plus 4, then if you plug in -4 here, you get 1 over -4 plus 4, which is equals to 1 over 0. So, and this is undefined, and it creates a vertical asymptote, which is a point of discontinuity, an infinite discontinuity, by the way. So this is an example of an infinite discontinuity. Now, for jump discontinuity, an example of it is a piecewise function. For example, if you have f of x is equals to, let's say, x squared plus 2, then this is the formula when x is less than -1, and then you have x plus 5 when x is greater than 1, alright, or greater than -1. So this is an example of a jump discontinuity. It's only piecewise function that can give this kind of discontinuity. Then whole is when you have something like x squared minus 4 over x minus 2. You know, you can factor out the numerator. If you factor numerator, you're going to get x plus 2 x minus 2 over x minus 2. So this and this has cancelled. That's the whole. Remember, we said that whole is a removable discontinuity. So by cancelling this x minus 2 and x minus 2, we have removed this whole. That's why we said that whole is a removable discontinuity. Thank you for watching. Remember to subscribe to my YouTube channel, like my videos, drop your comments, and share with your friends. See you in my next video.